You wouldn't freeze. You wouldn't explode, and you wouldn't scream. If you were suddenly exposed to deep space without a suit, your body would begin shutting down before your brain fully understands what's happening. You are outside, adrift in the silent, unforgiving vacuum of deep space. What happens next is not what you've seen in the movies. You wouldn't shatter in a gruesome spectacle. And you wouldn't scream, because in the absence of air, sound itself ceases to exist. If you were suddenly exposed to deep space without a suit, your body would begin shutting down before your brain fully understands what's happening. The transition is brutally swift. In less than 10 seconds, the fundamental systems keeping you alive would start to fail, one by one, in a silent, cascading collapse. This is exactly what happens to a human in the first 10 seconds in deep space. The very first sensation is one of profound nothingness. The instant you're exposed to space, everything familiar disappears. There is no air, no pressure, and no sound. Space is completely silent because sound waves need a medium, like air, to travel. Without it, even the most violent cosmic events unfold in absolute quiet. The only sounds you might perceive are the frantic internal workings of your own body, a dull thumping of your heart that quickly becomes erratic. Your body, a vessel evolved over millennia to thrive under the crushing weight of Earth's atmosphere, still expects that constant, reassuring pressure pushing against it. It's the same pressure you've lived under your entire life, a force so constant you never even notice it. But suddenly, it's gone. Your lungs react automatically. They try to exhale, to equalize with the surrounding void. This is your body's first and most critical reflex. If you panic, if your instincts scream at you to hold your breath, the consequences are immediate and devastating. The air trapped inside your lungs, now facing zero external pressure, expands violently. This is Boyle's law in its most brutal form. Your lungs would rupture almost instantly. This catastrophic injury, known as barotrauma, would send air bubbles directly into your bloodstream, an embolism that could reach your heart or brain within seconds. That alone can be fatal, long before any other effect of space takes hold. Ironically, your only chance, your first and most important act of survival, is to do the opposite of what every instinct tells you. You must let the air escape your body, emptying your lungs to face the vacuum. It is a surrender that might just keep you alive for a few more precious seconds. As the pressure plummets to near zero, a terrifying cascade of events begins inside your body. It's driven by the laws of physics governing the liquids within you. Your body, adapted to Earth's atmosphere, is suddenly unprotected. The first 2 seconds are a moment of surreal disbelief, a profound sense of wrongness. The most dramatic effect is on the gases dissolved in your bodily fluids. Like opening a can of soda when the pressure is released, dissolved gases instantly fizz out of solution. The same thing happens in your blood. Oxygen, nitrogen, and carbon dioxide, held in liquid form by your blood pressure, begin to boil. This isn't boiling from heat, it's a cold boiling, a purely mechanical process driven by the absence of pressure. It's a phenomenon called embolism. Within 5 seconds, tiny gas bubbles form in your bloodstream, starting in the venous side where pressure is lowest. These bubbles act like tiny embolisms, clogging smaller vessels. Your tissues are now being starved of oxygen. It's boiling out of your blood, and the blood itself can no longer reach them effectively. This process isn't confined to your blood. The moisture on your tongue begins to bubble, and the water in your soft tissues vaporizes, causing them to swell. Your tongue swells, and your skin becomes puffy, though its natural elasticity prevents you from exploding. The delicate tear film that protects your corneas evaporates almost immediately, exposing them to the harsh vacuum. Your cardiovascular system is in crisis. Your heart tries to compensate, beating faster to circulate blood that is becoming a frothy, inefficient mess. But it's a losing battle. Your blood is losing oxygen faster than your heart can deliver it to your brain. By 8 seconds, your brain begins to starve. The human brain is extremely sensitive to oxygen loss, a condition known as hypoxia. It consumes about 20% of your body's oxygen, and without a constant supply, it cannot function. As oxygen levels plummet, your brain initiates a desperate triage. Higher cognitive processes are the first to go. Your vision begins to tunnel as the oxygen-hungry cells of your retina fail. Colors fade, and your peripheral vision collapses into a narrow point of light before winking out entirely. You are likely still conscious, but your thoughts slow to a crawl. You may feel confused or strangely detached. This is the threshold of losing consciousness. As oxygen deprivation worsens, your muscles begin to fail. You lose motor control and your body goes limp, not because you're calm, but because your brain no longer has the fuel to send a single command. Panic itself becomes impossible. It requires oxygen your brain no longer has. There is only a profound, encroaching silence as the last flickers of awareness fade to black. Somewhere between 7 and 10 seconds after exposure, your brain shuts off completely. The electrical storm of conscious thought simply ceases. You lose consciousness. There is no pain, no dramatic moment, and no awareness that it's happening. Just a silent, swift fade to black. If rescue were to occur within the next 30 to 60 seconds, survival might still be possible, though severe injury would be likely. Beyond that 90-second window, the lack of oxygen begins to inflict irreversible damage on the brain. The cascade is swift, and the final outcome, inevitable. Death follows. But what does that moment actually look like? Contrary to what movies have so vividly and incorrectly shown us, you do not explode in space. Your body does not burst apart in a gruesome spectacle. Our skin is a remarkably strong, elastic pressure vessel. It's more than capable of containing our internal body pressure, even against the perfect vacuum of space. So while the pressure differential is immense, your body remains intact. Your eyes do not pop out of their sockets. The fluid pressure inside your eyeballs is nowhere near high enough to overcome the tissues holding them in place. However, the moisture on their surface would boil away almost instantly. And without atmospheric pressure, the tiny blood vessels in your retinas could rupture, leading to permanent blindness even if you were rescued. Space does not kill you with explosive violence. It kills you quietly with the simple, unforgiving laws of physics. Freezing is not immediate either. This is another common misconception. While the ambient temperature of deep space can be as low as -270 degrees Celsius, a vacuum is the best insulator there is. Heat transfer requires a medium, something to conduct the warmth away from you. In the near-perfect emptiness of space, there is almost nothing to pull heat from your body quickly. The only way you lose heat is through thermal radiation, which is a surprisingly slow process. You would lose consciousness from lack of oxygen, and your heart would stop beating, long before your body had a chance to freeze solid. The end, when it comes, is silent and internal, a stark contrast to the dramatic fiction we've been shown. Earth surrounds you with atmospheric pressure, breathable air, and thermal balance. You don't feel these things because you've never lived without them, but the moment they're gone, survival becomes a countdown. The most terrifying thing about space isn't how violent it is, it's how indifferent it is. There's no explosion, no warning, and no drama. Just silence and a clock you can't stop. Space doesn't kill you because it's cruel. It kills you because you were never meant to leave Earth. And the moment you do, the countdown begins.